Okay, last question. Again, this collinear idea isn't actually in the syllabus just now. That's mostly with vectors. The point is, if I know, is it still in? It might still be in actually, but it just means that you're checking to see that line AB and line BC both have the same gradient and they share B as a common point. That's it. I think it maybe get taken out straight line actually, but yeah. So I'm not too fussed about that. But that's if we want to do that. I'm more interested in the second part, which is determine the equation of the circle with centre D. So to do that, I would first of all label up what I've got and have a think about what I can sketch on. Okay, so we'll just zoom in. Let's see what I can sketch on. So I know that A is -7, -2. I know that B is 2, 1. So yeah, you can do the gradient AB and gradient BC and make sure they're the same and say that B is midpoint. That's very easy. But it's definitely this last one. It's the circle question, which is trickier, and that's 17.6. Excellent. Now the circles have got the radii. RA is √10. Okay, so again, I'll keep this in the same color. So I've got √10 as a radius. So that's √10, which means that distance over there is √10. You know, B is 2 of RA, is twice the size. So that means that this bit in here, and I'll just do this as in a 1A, that means that is going to be 4√10, isn't it? Because you've got a radius here and a radius there. So you have 2 √10s and 2 √10s, so you have 4 √10. And this one is RA plus RB, okay? So I've got 2 √10 plus √10, so that's 3 √10, which makes the whole thing 6 √10. There we go. So I've got 6, I've got 11, I've got 6, I've got 8 √10s in total. So that whole thing is, not, sorry, right, 6, 7, 8, 9, 10, 12 √10s. So diameter is 12 √10s. So I'm going to have 6 √10s is equal to my radius. Radius over there, actually. Yeah. So just a wee bit of visualization, trying to think on that. And I would be, if I had more space, I might have labeled it up both radii, but I've just put it into diameters. Okay, but that's a very easy one to mistake. If you don't keep putting in your diameters or whatever. Okay, so I know what the radius is. I need to get the center of the circle. Okay, so let's have a think. If I start on the -7, -2, I'll try and put that in red actually. Keep it the same. So I start on -7, -2. I want to get up to the point D. Okay, so I want to get all the way up there, which means that I've had to travel one radius, so 1 √10, another 4 √10, so 5 √10s, which I'm just going to call kind of radius, 5, effectively 5 radii of this. In fact, no, I'll say √10, I'll say √10. So if I travel up 5 √10s, 1 there, and then 4 in this circle, 5 √10s. And that's landed me on point D, which is the value I'm trying to find. Okay. Now, what I do know, okay, I know that if I start on -7, -2, and I go up to point B, which is 2, 1, I have travelled 1, 2, 3 √10s. Yeah. So let's see how horizontal and vertical that is. So the difference in the x's is 9, and the difference in the verticals is 3. So if I wanted to move a single √10, just 1 √10, that would be a third, wouldn't it? So that would be 3 here and 1 here. So all I'm doing is dividing this by 3. Because I'm saying, well, 3 radii or 3 √10s will get me, along 9 and 3, but I can break that up into 3 steps, kind of like this, okay, which is what this little triangle here is. So I'm just wanting 1 step. Yeah? So I don't want 1 step though, I want the 5 steps. So then I need to take this, times it by 5. So that means I'm going to be moving 15 along, and I'm going to be moving 5. Yeah? And also, Let me just double check my, yeah, these are all positive. Just check the direction of travel. I probably could have put a wee arrow just to note that I'm going up the way, you know. That's fine. So it is an add. So -7 plus 15, that's going to give me 8. And -2 plus the 5 is going to give me 3. Okay. So that's quite a nice little question. You know, that pops up now and again. And I've got the radius as well, so then I just need to work out or just put it all together. So I'll come down here. In fact, I'll put it over here actually. No, I'll come down here from space. So I've got x, take away 8, so we change the sign, don't we? Is equal to x, not equal to x, 2 plus y, take away 3 squared, and that's equal to the radius squared, which is 6 root 10. So 6 root 10 squared. So that's going to give me 36 times 10, which is 360. So there we go. So just because it's on an angle, just a little bit of thinking with that one involved. I think just the way they've laid out the radii just makes you try and think about how far you've moved. So that is the end of the series. I'll just put that. Let's get rid of that. I'm just going to zoom right out. And we'll just have a quick chat and look how rubbish my circles are. So the actual equation, a few easy marks for them. Don't forget when you're looking at your equations, you're given the generic form at the front, so there's lots of help there. But for this form, you know, it's change the sign and divide by 2. Change the sign and divide by 2. When it's this way, it's just change the sign. So the centre here is written like this. Yeah, just change the sign. When it's written like this, half it and change the sign. Okay, so that was our first big one. We were then looking at tangents, which is more of an equation of a straight line. So just visualize it, get this gradient, and then do the change the sign in 1 over. They were quite straightforward. They only got a little bit trickier here when it was asking, you know, is it a point of contact, which we discussed you can do by either factorizing, and if you have equal roots, it's a tangent, or you do the b squared minus 4ac, and you say if that's equal to 0, then it is a tangent. Okay, so we talked a little bit about how you could prove it is or it isn't as well. That was quite a common question. And the other question was working out points of intersection. So again, you know, substituting in to the equation and then factorizing to work out the points of intersection. These two are just slightly trickier. You know, this was more like a quadratics question where I wanted to know the range of values, so a wee bit trickier. And again, in here, just more of a visualization thing with the intersection and turning that into a you know, bigger circle question. But don't forget, you know, when you're looking at intersection, one side of your equation, if one side is equal to the other, then you've got 1 point of intersection. You've got tangency. So you've got one. You're on the line if this side equals that side. If one side, this side here is less, you're inside the circle. If this side is greater than, you're outside the circle. So that's the kind of the main point to take away from the intersection. You know, the less than, you're inside, greater than, you're outside. And for the last bit, it was just a little bit of problem solving. A lot of working out centres by going in steps. So just, you know, have your diagrams ready, you know, draw out your triangle and then, you know, scale it as you need to. That's very important. And yeah, just take your heading, CRE, and just take your time. So I hope I've demonstrated that there's a lot of easy marks. Certainly equations of a circle. I think the tangent stuff was quite straightforward. And some of the trickier ones, much easier if you start to draw them and visualize them. You can see there's not a huge amount of working. For some of these, it's more visualization and being careful with your algebra when you're substituting in. Watch out for those big, where is it? Like in, let's watch that one over here. Watch out for those big substitutions where you're going to take a common factor out to make factorising easier. So watch out. If you're not having a nice time here, if there's not a nice common factor, you've probably made a little mistake somewhere. So just watch out for that. So yeah, I hope that's all helpful. That's the 4 main types of question. A standard, what's the equation, your tangent, your intersection, and then some problem solving. Okay, so yeah, best of luck, and that is the end of the series.